So welcome back. Unfortunately, the nice sessions of beautiful notation and theory, philosophy are over. And there's a block of people trying to push technology at you, distributing software and creating user interfaces. Our first speaker in this section attended a workshop given by Jason Rivers about a year ago on Docker, which Jason was using internally at Dyalog to manage the build processes and various other jobs that we do overnight, building, testing the system and so on, and fell totally in love with the technology and believes it is Google's gift to APL. So I'm going to follow on from my presentation on Monday, where I just showed some examples of how you might use some of these containers. I'd like to try and explain a little bit more about how they work. So the cloud computing here really means mostly a specific technology known as Docker. Docker Hub is what I'm going to talk about, how APL can be used with that. So the definition, cloud computing, what's that? Well, essentially using somebody else's computer. Usually they've made it available to you, and you're paying them something. The highest level, this is something you probably all use every day if you're using Gmail or Dropbox or any of those types of tools. You're using something, it's running somewhere, you don't really know where the code is running or where the data is being stored. They call that software as a service. I hope there are no real experts here who are going to quibble with me over these definitions. The next layer, I understand, is something called platform as a service, where service providers installed their own platform, might be PHP, MySQL, ASP.NET, some kind of framework for developing applications, and you log on and use that. And then at the lowest level, they have what they call just infrastructure as a service. So they've created a virtual machine host and attached it to the internet, and they're just allowing you to create your own virtual machine. You can install anything you like and do whatever you like. And this talk is really about using Dialog APL on infrastructure as a service. So all you need to do is pick a provider, upload, create a virtual machine, and what you save is essentially the hassle of having, buying hardware, installing it, fixing it when it breaks, replacing boards when they break, etc., and having an internet connection. The hard part is, of course, the picking a provider. There's dozens of them. You've probably heard of the first 3 or 4 there, but that's not even scratching the surface of the number of different providers there are. And they all have different pricing models and so on. We've been focusing, of course, on the most widely used ones, experimenting with. And then you need to install the software for whatever service. So, although you're using IIS, your intention is probably to provide either software as a service or platform as a service yourself to your customers. So you've got some of your software, your framework that you need to install, the APL interpreter, a web server, web service framework, database that you might want to use. And this is really where this Docker container technology is just pure magic. Every time I learn a new feature of it, it's just like, wow, that just worked, and it was so simple. So, this piece of text here completely describes a machine that you're setting up to run somewhere. Could be on your own computer, could be on the internet. So you have a base image, which in this case is a particular version of Linux. You add some files that you have created or downloaded. So this is the first file there is the Dyalog version 17 installer for Linux. Your application code. So you're saying add this file, and then the second argument is the place in the file system where you want to put it. So your application /test you want to put into /myapp in the container when it's built. Those are the add statements. The run statements are statements to be executed when the container is built. So when you say build this container, it's going to run dpkg, which runs the installer from that deb file that's downloaded. And then it's going to use git clone to bring in the latest copy of JSON server, which is our web service framework from the internet, and put it into a folder called /JSS. And then we set a couple of environment variables that control how JSON server starts. And then the CMD is the statement to be executed when the container actually starts. And that's it. This Dockerfile completely describes a machine which is going to run your application on using JSON server and Dyalog APL. And this is really the only part that's specific to your code. Of course, you have a choice. You have to decide whether you're going to bring it in from a folder or you're going to do what I and various other people have been trying to convince you of over the last few days and actually have your application in a GitHub repository and clone it from there as well, right? So you can, these two are a choice that you need to make about how you're going to do it. And here's the slide that Kai was trying to show you that wasn't on the machine that he was using. And he's absolutely right. Install Git and learn how to use it. I think maybe we should have an entry-level workshop on Git and GitHub next year. Try and get people more comfortable with it, because it will really make your lives better. Right, so we've got this file. It's the same file you saw before. I've just taken out the blank lines to give myself a little bit more space. You go into the folder where it is, where that Docker file is, and you say docker build, and the -t is the tag, the name that you give it. So my company, my app-test, and the dot just means, is a reference to this folder. And then a second or two goes by, and then you're in a position to say docker run, mapping port 8080 on the container to 8081 on the host machine, mapping some folder on the host machine into /data in the container. So that creates a live link between a folder on your machine, on the host machine, and the container. And -e allows you to set any environment variables that you want to set dynamically that weren't declared in the Dockerfile, or override things that were in the Dockerfile, and then the name of the container. And it starts up in a split second, and you're running. And that's what you saw me do a few times on Monday. So the options, just to quickly go through those, the docker run command line, so -p creates a mapping between a TCP port. Typically, you'll build the containers to always use port 80 or port 8080, but when you start them on your host environment, that port might be used for something else. You might start 7 of them and need to map the ports to different ports so you can access them using different port numbers. The E environment variable, V for volume, mounts a volume, the host folder mounted as the client folder or the container folder. And then T and I, which you unfortunately need to supply with all of the Dyalog containers, because there's currently a problem with our Linux interpreter that it will not run detached. So you must have a TTY allocated. And then the --rm says that when this container is finished running, whatever changes happen to its file system while it was running, just throw them away. Otherwise, the system will store them with the container, and the next time you start it, changes may have been made. Right, so those two commands there, the build and the run, which we just saw, are what you would use if you were just experimenting with this on your own computer. But of course, the purpose of this is to do cloud computing. So we'd like to push the image to Docker Hub. So Docker Hub is something like GitHub, except instead of storing source code, it stores Docker container images. So the things that we've built. So after we've done a build, we can log into Docker, provide our credentials, push with that name, and now this last statement doesn't work just on our own laptop where we built it, but it will work on any machine connected to the internet that has Docker installed. And if that's a public image, that people won't need any credentials to use it, but you can have it be a private image so that only the people you want to have access to it. Then you have to pay Docker Hub. You can have as many public images. This is a very common model now for open source services, is that you can have as many public images as you like, free of charge, but as soon as you start creating private images, you have to pay them some money for it. Yeah, so typically if it's something, if you're pushing it to a repository, there'll be a prefix which is your ID, your organization's ID or whatever on the Docker Hub account that's being used. So GitHub for the source code, Docker Hub for the images gives you really, really simple distribution of applications to any machine. Oh, by the way, did I say you need version control? And VS Code, which has in the space of a week become my favorite environment for doing anything, you'll see that, does this work? I've installed, in addition to Gil's APL plugin that gives me APL syntax coloring for all my APL code, I've installed the GitHub plugin, which tells me I've got 41 changes I haven't pushed. And if I just click on any one of my functions that I've been editing, you'll see it gives me automatic changes. And when I click on one line, you can see the cursor is there. It says M. Kromberg 4 days ago. Anyway, so that's more Git and GitHub and integration with other tools. Really, we're talking about containers. And they are truly stunning technology. In addition to making distribution very simple, the sort of real claim to fame, the reason why I think people started using them, is that they allow many applications to share a single host computer but remain isolated from each other without running a full virtual machine for each one of the applications. So the effect from the user's perspective is almost identical to virtual machines, but the operating system kernel is shared. And because of that, you don't have the startup time. You can start and stop containers in seconds. The operating system doesn't need to boot up. They just start just like that. And they consume very much less resources. Docker is hotter than hot because it allows you to get more apps up and running on the same old servers. And the reason for that is if you look at these two pictures side by side here, the one on the left shows you what you would normally do with virtual machines, is you'd have a virtual machine server which would have a host operating system and a hypervisor, so one of Microsoft, Oracle, whatever, virtual machine platform. And then you would create these, say there were 3 virtual machines here, 3 copies of Windows or whatever, or Linux, whatever the operating system is, and the libraries that go with it, and then your application would be up here. Whereas with a container, you have the same thing at the bottom. You have the server hardware and the host operating system. But then the Docker engine allows the applications to run directly on a single copy of the host OS, somehow magically providing isolation. I don't understand how it works, but so far it seems to. The 2 different colors you see here, it says binaries, libraries. You maybe can't read that very easily. What that's alluding to is that the Linux kernel is shared by different versions of Linux, but this could be Ubuntu over here and CentOS here. So you can have applications that require different Linux builds or different Linux versions on the same machine, but still all starting up in a split second. And of course you can see, the key thing is that the amount of space allocated to running your application and data, your stuff is consuming a much larger fraction of the machine, and of course since you're paying essentially for memory and CPU that you're using, you're essentially paying these days for the number of watts that you consume in the data center. It's much cheaper. So Linux is really key to this. The container technology was developed under Linux, and it works much better with Linux because of the size of the kernel. You can get Linux kernels all the way down to, what did we see yesterday? 2 megabytes. Yeah. Whereas Windows is still struggling to get below half a gigabyte. So that, with Windows, you can have Windows containers, but they really don't deliver the same kinds of benefits. If you can't move your application, of course you need to go for the Windows. But if you're really just running Dialog APL code, computational code, analytical code that uses SQAPL or Quad CSV or any of the new features, TC, Conga, etc., that we've developed in the last 5 years, all of that stuff works cross-platform. It's just the Windows APIs you can't call, and when we've got the .NET Core bridge, then you really will have everything that you need, I think. So you can install something called Docker for Windows. That doesn't mean you're running Windows Docker containers. So all of those of you who are on the Windows platform, if you need to experiment with this, install Docker for Windows, because it actually typically it runs a virtual machine operating system, Microsoft's Hyper-V, and it's actually launching Linux containers. You can choose between Linux and Windows containers, but if you want to use the Linux containers, Docker for Windows works fine. That's what I've been using for the last couple of weeks, preparing everything for the user meeting. So all of these commands here are available as command line prompt commands under Windows. This exactly the same way as Linux. They have exactly the same syntax, work in exactly the same way. It all works a little bit more slowly because it has to get into the VM and issue the commands. It's communicating with a VM that's running there. So, go to docker.com, follow the instructions. You need Windows 10 Professional, Enterprise, or Education, a fairly recent version. Right. So, there's a set of official repositories, so everybody who's anything has been uploading official repositories containing their software. Dyalog hasn't quite got to that point yet, but we do have an organizational repository where the images I was using on Monday are all uploaded. So there's a set of images up there that you can play with now that are based on pre-release, version 17.1, unsupported, non-commercial use for experimenting only. But by the time 17.1 goes out, they'll all be properly licensed, but you will still be able to get hold of them free. So there's currently this set of 4 public Dyalog containers. There's one which just contains Linux and a Dyalog interpreter. There's one, and all the 3 others are built on top of that one. So they all start with Dyalog 17 as the base image. Then there's one that adds JSON server pre-installed, one that has my server pre-installed, and then the latest edition is the one that has the Jupyter Notebook support installed. So if you want to run Jupyter Notebooks with APL in them, you just fire up that container. You don't, in fact, need to push anything into it. It comes with all of our Jupyter Notebooks installed. So the big benefit of the public containers is that instead of having a Dockerfile that looks like this, where the first 4 lines in this case are saying, well, install Ubuntu, install Dyalog, get JSON server, and then the last 4 lines there are your stuff, you can have one that just looks like this, which says, from Dyalog, JSON server, and then the last 4 lines are the same. And in fact, it gets so simple that you could argue, and this is what I was doing in the talk on Monday, I wasn't building Docker images at all. I was just saying, run this container, Dyalog JSON server, and setting a few parameters. In fact, I was using some scripts that make it even simpler than that we'll get to in a minute. But based on these public containers, you don't need to build anything. You can just map in some code, map some ports, set whatever environment variable is required to get JSON server to serve your application, and fire it up. Single command line. So I've tried to create, of course, security is the big issue, right? You put something like that out on the cloud, and it opens up a port, and now it's accessible to anybody. So hopefully I have time. Michael said I could have an extra minute or 2 to actually run this demo. So what's happening here is from the JSON server image, we set some basic environment variables, workspace size, where the code is, which port we want to open up. Then we set a bunch of JSON server parameters that have to do with security. So we're saying what kind, we want it to be secure in the first place, and then we're identifying where the certificates are going to be stored in this container that we're building, and we're identifying exactly which certificate files we want to use for the server itself when it starts. Then we're adding the folder containing our test certificates, putting that into /certs so that we can refer to the certificates in the environment variables. We're adding our application, which is the back end for the Zodiac server that you may have seen demonstrated in the webinars. And then we say, well, start it up. Yep. And so here's another screenshot from VS Code. What this is showing at this, so this server only has a single function you can call, called getZodiacData, which is used internally within the Zodiac service to just get hold of the core. You know, this might be your prices if it was a typical APL application. But then I've added this one line, so you get the pointer to the request as the left argument if you want it. And then we can dot into that, get hold of the peer certificate, so the client certificate, and we can get hold of the subject and the issuer. And then we can decide in the application how we're going to deal with it. So on the machine that we're going to use now, I've already installed Git, yum install Git in this case. I've installed Docker. This is the example from Monday. I've installed the Docker utility scripts and put them on the path. And now, the dangerous part of this talk. So I've dotted into that folder. I've got the Dockerfile that we just saw here. Yep, we've just seen that. I'm going to docker build -t Kromberg backend secure dot. And that's going to take a very short amount of time because it finds out that I've done it all already. And then I'm going to do a docker push. Doesn't really matter because I pushed it just before. I don't know why that's, oh, there we go. Well, it's using the internet via the Wi-Fi. And then I'm going to go to PuTTY, which is my TTY. I'm now logging into a virtual machine on Amazon. And there I'm going to say docker pull. Actually, let me see if I don't have that. Docker pull. It's already up to date, of course. And then I'm going to run it. I still have to, when I run it, I still have to provide the port numbers. And off it goes. And I will now start up a browser, and I will go to HTTPS. AWS DC is just a local definition I have in my hosts file. And why didn't that work? Bloody Internet Explorer. Sorry, I'll cut that out. Okay, so now the web browser has gone to this service and it's discovered that it's a secure service and it wants to know it wants a certificate from the client side. So I say, yeah, I'm going to allow that. And it's telling me that this is very insecure, and that's because I'm just using, these are certificates that are distributed with Dyalog APL, right? Björn has generated a set of test certificates. Of course, you should never use them in a real application because they're not created by a well-known certificate authority. But we've put them out there so that you can play with this technology and test that you can get it working. So I'm going to call the getZodiacData function. And you can see, no you can't. Now you can, that we've got the information about the certificate authority that issued the certificate, which is the test certificate authority. And it's issued a certificate to Morten Kromberg. And of course the crazy thing is that although the web service is protected, the ride session is not. I didn't bother to set that up, so I'm just going to go in and hack it and crash it. Oh, I should have stopped it first, sorry. Right, anyway, So that was an example of building and distributing a server, running it in the cloud. And where did I get to? Of course, I did all the typing there. But of course, as I love VS Code, it's got a Dockerfile add-in. And in fact, if I have this build file in there and I right-click on the M there, I've got build image down there. So I didn't actually need to do any of that typing. I could just have picked it off a menu. And then I can go to the list of images and I can just select push, and it just pushes it. So the final little piece of magic that we decided to add to make it easier to use from our side is that there's a repository called, it'll be called Dialog something else at the moment. It's just in my private GitHub area. There are two folders called bash, one called bash scripts and one called win scripts, which are just identical scripts, just one written for the Windows environment and one for Linux. So these are the ones that you saw me use on Monday. So there's a dialog C where you give a folder and a optional write port that just starts the dialog container with your folder mapped in as app. JSON server, the -C stands for container. Maybe we'll think of better names for them. So the JSON server C takes a folder and you can give it an HTTP port if you want to use something other than 8080. And you can give it a RIDE port number if you want to expose the RIDE so you can debug it. My server C works exactly the same way, has the same syntax. And the Jupyter C is a little bit different because the thing you need to provide there is a folder containing Jupyter notebooks. Right, so set myself a little challenge here. See if I can do this in 2 minutes. Let's build an APL-based website from nothing in about 2 minutes. Stopwatch. I shouldn't waste time bringing up the stopwatch. No. You have to wait until I'm here and I've gone to the root of C. Start the stopwatch. Okay. Make directory my app 8 cd. Let's see, code my app 8 index.mypage. Come on. Class index, which is a my page. Function compose. Access public, yada yada. Add a heading level 1 saying hello Belfast. Add, and now there's an intentional error here. I'm flying dangerously. 1000 reshape lorem. How does it go? Ipsum. Can you read it? Tell me what it's supposed to say. Dolor sit amit. Yeah. Del and class. Save. Back to here. My server C, new app 8, 8080, 4502. Did I say my app? Yeah, thank you. See, the page isn't working, but that's not a surprise. That's expected because there's a typo. Yeah, it's crashed. Ooh. What? Oh, sorry. It looks like I had an old one that I hadn't shut down. So we're going to have to do that again. I'm not going to make the 2 minutes, am I? Anyway, it's still not working because we know there is an error in there. Did I? How does it go in DOS? Index, my page index, my page. Now, and here we go. So now, Control Enter. Add the .p. Escape, yes. And we're running. Yay. Where's the timer? Ah, okay. 3 minutes. I screwed up. Sorry. And right, so we don't have time to get into the next couple of slides, so just flash them up really quickly and finish. Come to the workshop tomorrow. So you can start. So here I'm declaring 2 services that work together. I actually showed that on Monday. So I've got an engine and a website running on different ports. So you can create a text file that says, don't just start one thing, start 2 things on different ports, and they'll talk to each other. And this even supports scaling. So you'll see down here at the bottom, there's a mode replicated, replicas to an endpoint mode virtual IP, which actually gives you a round robin. So it will load balance and send your requests alternatively to 2 different copies of the same server, who both are running on port 8080. You don't need to make any changes to them. And that's it, really. So, I mean, we haven't really been working hard on this for very long. We're just starting to see the potential. We can see, obviously, we need a tamstat container, so you can run tamstat, HTML version of tamstat on any machine just by typing a command. An isolate server that makes it easier to run isolate processes on multiple machines. And, yeah, I claim it's already really easy, even with the limited amount of work we've done. I haven't really got into it yet. It's easy to deploy APL applications. In addition to the free licensing, we're also thinking where people will need to sign up for a license. We're thinking we could have some premium images where you just rent a machine from Amazon, and they'll collect the money and give us something, and you won't need to have a commercial relationship with us at once. If you want to know more, come to the workshop tomorrow and follow the webinars. I'm sure there'll be much more about this in the next few months. Right, I have used the 5 minutes that I think Michael said I could have. And thank you.